Okay, then we are ready to start again. And I'm happy to introduce Dan. He's based in Cambridge in the UK, originally from some different country. And I essentially met Dan on Twitter. And earlier this spring, I went over to the University of Cambridge to participate in a research project that is going on there. And at that moment, at that time, I have been looking a little bit into Script, which is Dan's company, and I, essentially I just emailed him and said, hey, I would really like to come and talk to you about your products and solutions when I am in Cambridge. And he said yes, and I essentially just walked into his office, sat down for an hour or two, and we discussed lots of cool things. And afterwards, I told him, you should really submit for PasswordsCon to do a talk. So by that, Dan, the stage is yours.
All right, thank you. Hello, looks like I'm not the only one who's feeling like it's early hours. Yeah, right, so I should try to be close to it. I'll talk about stuff that we kind of started a bit working on at the beginning of the year, but really hit it hard about 2 months back. So I was hoping to show you live demonstration of how the device or system works, but well, I'll probably leave it for 1 or 2 weeks time if you're interested. So our vision, I've been working sort of security with cryptographic background in academia, and I've been working for Deloitte as well. So I saw how banks are doing crypto. And I realized that one of the problems with crypto is that if you want to do it reasonably well, you need specialized hardware, and it's hard to get and even harder to use. So our vision was to build something that is easy, secure, and affordable, and anyone basically can use it. Just to give you an idea, one box, which is called hardware security module, will cost you about $15,000 straight off, and then probably $5,000 every year for support. It's not easy to use, and the support you pay for will not build applications. You have to do it yourself. So easy and secure and affordable. The other point was to provide application support and not cryptographic functions. Usually, if you want to do something or build, you don't want to do AES encryption, but you want to protect email or protect passwords or I don't know, make your credit card number storage more secure. And the last goal was to build something that is scalable. So you can use it if you want to 5 times a day log on to your website, but the same way you can use it if you got 100 million customers using your service. So I got 2 scenarios that kind of show what we wanted to do. So imagine that you're CTO or Dropbox or Bank of America or something, and your team built a new function for your business that will bring you a lot of money. You've tested it, and now you want to turn it on and put it into all your virtual machines that you got around the world. Well, a bit of problem is that because you want to provide some kind of security, you need to distribute encryption keys around the world. So the idea is that you take, I don't know, few lawyers, give them some physical tokens with encryption keys and potential description how the key should be used, send them to the nearest data center, they plug them in, they use key bearer, they can use some kind of authentication tokens, and when they leave, a magic happens and that key is suddenly available in all virtual machines around the world, and all your customers can use a new application. So the second scenario is sort of the other end of spectrum. Now your CEO, CTO, post-delivery boy, anything in your own startup. You're very good in developing applications, designing new user interface, but you have no idea what security is about. But your idea is about creating a virtual world, and it would be quite cool to create some assets that you can protect so no one can steal them. So what you do, you go to website, you select from the list what kind of functions you want, you click on them, and after a bit of description, you can copy-paste a few lines of code that you just put your application, and off you go, all done. So these are visions or scenarios that would really like to see. So I've been talking about secure devices, service in the cloud, and the next thing you probably say is, well, I don't really trust it much. So I try to say what I mean by those terms. Secure devices, tamper-proof devices, fairly expensive specialized kit. When you try to open it, it will erase everything that is inside. It would get certifications, so there is like worldwide programs that will certify devices called FIPS 140-2. I don't say it's perfect, but it's probably the best we can do at the moment. And what the devices do is that if you put something inside, it will never leave the device without encryption. So if you put in a key, you can only export it as an encrypted key. So even if you leak that, nothing happens. Hosted service, it's kind of tricky because we like convenience of having our applications wherever we go. On the other hand, we don't like big companies to own our data and be able to pass the data to whoever they want or ask them to do. So trust is a key word here, and we found after publishing sort of results of our first proof of concept, there are two types of proofs you can, or you should, or probably must if you want to be successful, provide. One is very easy to understand, well-looking proof that anyone can understand and say, yeah, that looks cool. And then there must be proper proof that will actually show someone who understands the stuff, who knows how cryptography works, what kind of threats are there, can do reasonable risk analysis, say, yeah, this stuff is actually really good. Don't know, my feeling was that the first one is probably more important, but I will leave that to your judgment. Another sort of interesting fact that I learned, I didn't realize that much before, was that a lot of people are willing to discuss with you security, but if you try to explain what you do, they slightly, slowly move the goalpost, saying, all right, you do that, so what about this? And they say that every single problem is the biggest problem they have, without actually putting behind it some kind of reasoning. What is your threat and what is the risk of that threat happening? And do you want to protect it, protect yourself against it, or is it all right? So, passwords, probably one of the main reasons why we're talking about passwords are large-scale password leaks. If it wasn't for them and someone sometimes just stolen someone's password, it would be part of academic conferences, but probably not so widely visible. I got a couple of slides of what big companies can do or are doing. Basically, what they try to do is to separate logic, business logic, into several sections or layers that are isolated. So the thing that your browser will hit is probably a web application that may contain some logic, maybe not, but certainly will not contain any user or customer data. Once the request is received, it will be forwarded onward to actual business logic that will have access to customer data, will provide whatever function you want to get, and if the company is really good, it will have another layer that will do the authentication. One reason for that may be just centralization, making authentication basically just one backend system that will serve all number of different applications. So each of these segments will be firewalled off, may have different physical access, different implementation methods, and so on. Actually, they are really good, so somewhere here in the corner they will use one of those expensive cryptography devices to actually store keys that are used to protect your passwords, secrets for OTP, or whatever. If you build your own web application or you're using a blog or CMS system, anything like that, then you certainly can't do that. You very often end up with basically just one space that contains web application, business logic, and passwords and data, use data as well. The internal part is pretty much empty. And once someone hacks into this, you're done basically. They can export or dump whatever they want. Still, we're talking about passwords, and I believe that passwords are not dead, as many articles try to say. And there is a few reasons for that. So some say that OTP is the best thing to replace passwords. So my question is, so why do I have to enter PIN or even password with OTP if it's a replacement? Another thing is change response. It's quite cool. It's very nice. Basically, if each time I want to log in, server sends me something that is unique, will never repeat, and I have to do some kind of computation. The problem is that to do the computation, I need something to do it. So either I have to have it in my pocket or somehow plugged to a computer. Biometrics, that works pretty well for the police when they want to identify you, but not that well when the reader is in your bedroom and you can play with it and do whatever tricks you want. And also false rejection, false acceptance rates are quite high for many of the techniques or technologies that are available. Someone mentioned here before Project Pico in Cambridge, which basically what they try to do is verify your identity with number of small devices that can talk to each other. So if you got 4 or 5 of those devices that can talk to each other, they can establish your identity, provide authentication credentials, and then automatically log you into a computer if you're near it. If someone just steals your mobile phone or earring or a couple of those items, it will not help them. So I think that passwords are here to stay for a while. And the question is what we can do with them. Yeah, here is one comparison of passwords and OTP that some people don't fully realize. When you use password-based system, then the database contains scrambled passwords. So I type in my new one, the system will scramble it, compare the scrambled versions, and says yes or no. So if I hack the server, I get scrambled version, I have to do some kind of work to figure out what the original password was. If I use OTP, then I will use something to compute my OTP code. It will go to the server, but the server has to do some computation. And it means using the same secret that is used for computing every single OTP value from now till the end of the time. So if someone hacks my server again, they get that secret, and they don't have to do anything because that has to be stored in plain text. So OTP is great to introduce freshness in terms of values that I send when I try to log in, but not so good if I just want to simply implement it in software from the server's point of view. So what is the main problem of passwords authentication? So here is a small schematics. On the left there is like me user. I may use some kind of device that will help me to connect to my PC. On that PC I can have another piece of software that will help me improve security. It can be specialized authentication module or something else. And that will send credentials to the server, the backend that will do authentication and will say at the end yes or no. given the publicity and basically the importance of leaks or hacks of servers, probably the last bit is the most important or dominant at the moment. So let's try to find out if we can do something, if we can help it somehow. So back to the initial idea. I mentioned HSMs that you can buy today. Basically, when you buy it, we buy a box. So you pay, whether you want to use it little or a lot, you pay the fixed price. It's not that powerful. It can do about 6,000 RSA encryptions per second. It's even worse on symmetric encryptions. And it's very hard to manage in terms of key management. So if you want to push your own keys inside, it's not so easy. What we embarked on doing or building is something where you pay as you go. It will be much more powerful. It will be very fast for symmetric encryption as well, so you can use it for cloud applications when you want to encrypt large amounts of data. And foremost, it has to be very easy to manage and use. So basically, it is cryptographic device or as a service that will be suitable for the cloud and available through the cloud. So in about January time, we built sort of proof of concept when we said, all right, so let's use one of the dongles we got and implement very simple password encryption for servers. The idea was that instead of hashed passwords, the server will store encrypted passwords, or HMAC, so it's not reversible. But if someone tries to hack your virtual machine with your CMS system, all they get is basically just encrypted file. So you can even publish your passwords on your own for anyone to download. It will not help them. So it did that. It works fairly nicely. Basically, if you want to use it, you just use, basically open the file from URL where your dongle is sitting, and you can use it. So the hardware is plugged to the device, whether it's Raspberry Pi or your server, doesn't matter. On top of that is built a web service that is basically interfacing the hardware device with your client. So from PHP, Python, Java, any language you can basically, using just a couple of lines of code, quickly implement or start using this. Even though it's very cheap and very small, you can still do about 200,000 logons per day, which is not that bad. So we were quite encouraged because people seem to like it and it got some kind of traction. So we thought maybe it's got some legs and let's build something that would make it proper product. So we started thinking about system architecture. And because we played with smart cards a lot before, we've done a lot of work with smart cards for a number of different applications. We thought, let's build something on smart cards. The advantage is that smart card is actually as secure as that very expensive HSM. In terms of security certification, you can get the same certificate for smart card as for this. Now, what if we put, let's say, 5,000 of smart cards into a box? We get very big, fairly reasonable device with quite significant computational power. But because we got so many of them, we need to manage it somehow. So we split them into application cards that will actually do the stuff. There is some control card that will help manage keys that are used by smart cards. And there is some semi-trusted controller, which is basically normal PC with processor. So if you want to use it, if you want to push some kind of keys inside, you will use seed card that you can plug inside. Doesn't matter which way you, whether you push data, your customer keys into it at your premises or do it some other way. Basically, because all the devices create sort of cryptographically secure cluster. Once it is inside, it never leaves the device, or even smart cards unencrypted. So basically what we do is that we move the secure boundary of secure space much closer to the data where it is processed. It's basically just around the microcontroller, which is a smart card itself, the smart card chip. That allows us to put it in a box with a normal PC, Pentium processor, or whatever. because that one doesn't have to be fully trusted, because it will never see plain text data or plain text key unless you want it. So for prototype, we're thinking what we want is very simple management operational API, so it's easy to use to deploy. So we're thinking, shall we use for something standard like PKCS11, which is standard cryptographic API, or shall we build something that can be tailored to applications? So if I just want password protection, I can use 1 or 2 functions for that, and I don't have to worry about the rest of the standard and implement it. Having said that, PKCS11 has got a lot of problems on its own, and there's quite a bit of research and few companies that are making money just to show which products have which problems. Because you've got so many small microcontrollers that can work together, we definitely want to do some kind of load balancing and scalability. We can do that. We can dynamically allocate smart cards to users that are using device at that moment most. So if you suddenly got a lot of work to do, you can use basically the whole device. If you use it little, other users can use it more. The design goals, the first one is simplicity. Make it very simple to use. Don't put in there any options. Once you put option for developers, they will try to think about the options and they will probably choose the wrong one. Scalability, clusters, being able to use disaster recovery production system, make it scalable. If one device fails, you can easily switch over to another one and try to focus. So solve one problem, which is basically just protect keys for the back end and allow users to use them securely. So where we are now, so you got the first rack mount with some cards inside. We've designed sort of extension board. So you got some development platform. It's about 9 inches long, so it's not very big. And this board allows us to do about 1,000 crypto transactions per second, which is comparable to big HSMs. The difficult bit, I said that once the key is inside the box, then it's easy. You can encrypt it when you export it and only decrypt it inside smart cards. The difficult bit is to actually push keys into that environment. There are different ways. I mentioned 2 scenarios at the beginning. One is sort of low cost. I want to do it very, very quickly and easily. Basically, one push, I can do some computation on my PC. The data is encrypted when transported. But actually, there is certain limit how much I can verify where the key is going. The opposite extreme is actually physically deliver the keys in 2 or 3 shares into the box, physically plug it to the device, and that way we can make sure that the keys don't go anywhere else. So the process is very simple. Basically, you can create object. We will verify whether it's correctly formatted. Once we are happy, then we can authorize import, which can be out of band, whichever means is suitable. And inside the device, so basically encrypt the object from transport form to usage form, and then it can be used inside the device. Using it, now basically you've got JSON interface. So we say on process data, I want to scramble a password. This is the password. This is the object ID that I want to use. So one of many that can be in the device. What happens inside? Request is added to the queue. Control pushes it to free card when it's ready. When it can see some kind of fluctuations in workload, it can optimize configuration. One thing that we are quite particular about is that even if you put the key in the device, you can't use it indefinitely. So if you want to use it, you have to issue something called tokens, which is time limited or use limited. piece of information that allows the card to use key only for, let's say, 10 encryptions. One that's done, it will have to ask for another token that will allow it to basically do some more use. So I didn't mention the magic at the beginning. Actually, what also the lawyers can do, that they can go to the same data center, unplug the card they left there, and very shortly all copies of the key will be destroyed or ransomware, basically, because there will be no more cards able to issue more tokens for using the key. So there may be just encrypted blobs of data that will be of no use. Basically, at the end, you get another JSON message with encrypted passwords, so you can store it in the database or compare it to what is stored in the database. I mentioned sort of a question about creating very simple, easy to verify API of one or two commands, or use some things fairly generic. Interestingly, when we discussed it with some people from banking industry, they said, do it simple. If you use PKCS11, it's very hard to find developers who can understand and implement it and use it correctly. If you use something that's got 3 commands, one is verify password, one is, I don't know, create user, they will probably get it right. I talk about user object, so it's not only the key, but it can be a sequence of commands that you can do with a key or set of keys. So you can create more complicated operation atomic within the secure environment. So you don't have to encrypt something, move it back to the client, and move it back saying, now I want to sign it. Or you can say, this is the data, and if you want to do encryption, then HMAC, XOR it with something else, you can do it all in one go. And the last is command versus session-oriented. We believe that it's much better if you can do it just basically simple kind of datagram approach, because you can do without hassle of creating sessions and establishing or managing sessions. So bottom line, we built something new, but in fact the security is built on products that are from vendors that have been manufacturing smart cards and secure devices for quite a long time, and they know how to do it. What we basically built is a layer on top that will allow to use a large number of sort of computational limited devices and give you scalability that you may need for applications in the cloud. Because the boundary now is much closer to the data, you don't have to protect the whole rack mount, so you can't open it, but basically the important is or the security lies in the smart card, because they are inherently hard to open and extract any secrets from. Having said that, you can still do a lot of work using only volatile memory, so if you unpower smart card, it will lose all the data that was stored in there. So yeah, and just repeating, smart cards can be FIPS 140 certified, which is the same level of security from cryptographic point of view as you can get from HSMs. But you can buy one smart card for 5 quid and one HSM for 10,000 quid. So that's it. That's kind of summary. Background is a couple of charts from first tests we've been doing. There is some more information you can find on the web that will update in the next couple of 2 or 3 weeks. And yeah, if you got any questions or would like to test it later on, just get in touch. Be very happy to get you access and work with you. So thank you, and any questions?
If I understood correctly, you talked about in your kind of the hardware architecture, you talked about the collection of smart cards, and then the controller was kind of listed as semi-trusted. And I'd like to dig into that a little bit, because it seems like that controller is what's granting access to the smart cards. So I would think that it would need to be really trusted in order to make sure that it's not granting access to a smart card to the wrong person.
Well, it is semi-trusted, but it really works as a kind of message broker. So it basically finds a card that's got the right object, and if you try to forward the message to the wrong card, basically the card just will not have the key that is necessary for operation. So if you want to encrypt data, we'll just encrypt data with different one. What I didn't mention is that in the sort of datagram mode that we're using at the moment, the encryption or data protection is end-to-end. So it starts in your application and adds inside the card. So if you want to put SSL on top, SSL will end at the controller. But end-to-end encryption of the data goes all the way to the smart card. So smart card can decrypt the data if you worry about it, as you can do all the operations inside and then encrypt, protect the result and send it back to you.
That definitely helps. Thanks.
One more question. Yeah.
Yeah. You have time for one more.
All right. One more question.